Managing debris operations is a complex and intricate task for any government at the local, state, or federal level. The U.S. Army Corps of Engineers, as a support agency to FEMA, is often tasked to manage debris operations in very large catastrophic disasters. This video will provide a brief overview of how the Corps manages debris operations during large-scale events. It is important to manage disasters just like other projects. A good preliminary estimate of debris volume and type is vital to determining the resources and contract requirements of the mission. Early debris estimates may be very rough, order-of-magnitude estimates. However, they are important to the efficiency of the operation. Understanding what types or waste streams are present is also extremely important to developing a functional project execution plan. This provides insight into efficiently, effectively, and safely managing the debris from cradle to grave, and can include opportunities for beneficial reuse or recycling of debris material. Examples of various waste streams include vegetative debris, construction and demolition debris, hazardous waste, household hazardous waste, white goods, soil, mud and sand, vehicles and vessels, and putrescent material. Segregating debris into the various waste streams as early as possible is vitally important to the debris mission. Segregating the debris at curbside is normally the most efficient and effective process. It's important to get this message out to the public early and often. This visual displays how to best separate and segregate typical disaster debris materials. Sectoring involves breaking the geographical area of debris management responsibility down into manageable size units. This is an area where mapping and GIS are invaluable. The sectoring process should be pre-planned and be included in the debris project execution plan. If contractor support is used, they will sector the area. If sectoring is set up in advance, the contractor's sectoring and work organization can be influenced. Sector boundary delineators can be roads, rivers, streams, natural features, or political subdivisions. GIS is an excellent tool for managing data relative to the sectoring process and tracking progress during the operation. In very general terms, a debris management project can be divided into 3 operational phases: emergency clearance, debris removal, and debris reduction and disposal. Emergency clearance of debris materials occurs early, usually within the first week to 10 days after a disaster event. The emergency clearance requirement can involve removing many varying types of debris generated by a host of different disaster events. It entails clearing critical transportation routes and public infrastructure facilities to enable police, firefighting, hospital services, utility services, and search and rescue work to resume after the disaster. In optimum situations, these important routes have been identified during advanced planning, and responsibilities for emergency clearance have been clearly designated. The Corps works closely with local government to identify the priorities and ensure a political and socio-economic balance. Work during this phase is extremely hazardous. Aggressive accident prevention and safety management is mandatory. Clearing and removing disaster debris begins even before emergency clearance is complete. FEMA determines what debris is eligible for reimbursement under the Public Assistance Program. USACE follows the published FEMA eligibility guidelines. Debris removal involves the operation of potentially hazardous equipment. In many cases, work is in closely confined areas, around energized power lines, in neighborhoods while children are out of school or adjacent to vehicle traffic. Safety must be the top priority. Ideally, debris is handled only once. It is loaded and hauled to the final disposal location whenever possible. However, in some situations, it is more efficient to remove debris, transport it to a site for debris volume reduction, and then transport it to the final disposal location. A debris removal operation may utilize a variety of debris collection methods, including curbside collection, mixed debris collection, collection centers, or a combination thereof. Curbside collection parallels normal garbage and refuse collection operations. Segregation of debris at the curbside is very important. Mixed debris collection provides for residents to deposit debris in a pre-specified location. This may be curbside or at points on the public right-of-way. This is not an efficient method of managing larger volumes of disaster debris, as it does not separate debris into debris streams. Collection centers involve residents transporting debris to larger collection centers and depositing the debris into facilities to accommodate segregation. These receptacles are often large roll-off containers. Using a combination of methods allows for varying the collection method to fit the debris stream. For example, vegetative debris could be handled in a curbside collection program, while electronic waste and household hazardous waste are managed by the collection center method. Managing the debris removed from the impacted areas must be consistent with all applicable laws, regulations, and done so in an environmentally responsible manner. Whenever it is the most efficient to do so, load the debris one time and transport it to the final disposal location. Often, it is most efficient to use temporary debris management sites as an intermediary location to reduce the debris and/or to stockpile debris for later transport to the final disposal site. Site selection and site design are important to the safety and efficiency of operating a debris management site and a debris disposal site. Experience has shown that certain equipment, such as a frameless dump trailer, is not suitable or safe for use in transporting disaster debris. USACE contracts do not allow use of this type of dump trailer. A functional and safe debris reduction site does not just happen. There are design considerations important to establishing a safe and efficient site. Examples of those considerations include taking into account prevailing wind patterns, traffic flow, highway access, surface drainage, load inspection, environmental factors, and completing a baseline environmental site survey. Air curtain incineration is an efficient and effective method of debris volume reduction. Very little, if any, smoke can be detected when the method is working properly. The curtain of air seals the incineration process. Temperatures can exceed 2,000 degrees Fahrenheit, obtaining a 90 to 95% reduction of the debris. The system does have to be shut down periodically, however, to clean ash out of the pit. Another method of reduction is grinding the material. Vegetative and some C&D debris may be ground to reduce volume. When planning for a grinding operation, make sure to provide a generous safety zone around the grinding equipment. Material can often discharge several hundred feet from the intake tub. Grinding provides an approximately 75% reduction in vegetative material. One of the best resource documents for disaster debris management is the FEMA 325 Public Assistance Debris Management Guide, dated July 2007. A link to the document is available on the ENGLink public site. Managing debris operations is a lengthy and expensive undertaking. It takes intense planning, collaboration, and cooperation from many government and non-government agencies. Fortunately, the Corps has repeatedly shown that it has the experience, support, and tools to effectively manage debris operations, and will continue to do so when it's asked during any and all future disasters.